Hello, this is a demonstration of the SSC to C translator in partial fulfillment of the degree of MSc Computer Science. First, why are we doing this project? There is a C model checker, ESBMC, which can detect runtime errors such as memory leak, deadlock, and etc. However, it is usually slow to verify a program. Thus, ESBMC has a built-in optimizer which is using SSA form to reduce unnecessary code before verification. We will talk about the SSA form later. So, ESBMC is not the only model checker. There are many more, such as CBMC, CPA checker, and etc. The idea of this project is porting the optimized code from ESBMC to other verifiers to achieve higher performance on this verifier. However, these verifiers cannot use the code from ESBMC directly, since the output is in SSA form. Thus, an SSA to C translator is required. So, what is SSA form? SSA stands for Static Single Assignment. It is also the characteristic of the SSA form. It ensures that each variable can only be assigned once. If further assignment is required, it will create a new version of this variable. For example, there are two codes are provided. The first code on the left-hand side is C code, and the second code on the right-hand side is SSA code. It is easy to see from the SSA code that the first assignment to X is unnecessary, since it is not used anymore in the later codes, so it can be eliminated. The second characteristic is the fetch function, which is special assignment decide which version of this variable should be used at the end of a control flow. For example, there is an if statement in C which controls the value of X and assign the final value of X to Y. However, in SSA, it needs to decide which version of X it wants to be used. The actual syntax of SSA code in ESBMC is more complicated than this. It is something like this, which is too complicated to be explained in the video. So, just let us start checking out the actual translator. Okay, this is the actual translator. In this translator, there are two folders. The first folder, SSA2C, contains all the source code to build a binary which convert a SSA code to a C code. And the second folder, SSA2C wrapper, wraps up the ESBMC and SSA2C, where ESBMC converts a C code to SSA code with optimization, and our SSA2C translator translates the SSA code back to C. So, before we can run the translator, we have to set up the environment with a setup file. So, this file will install every required library to run the translator. So, sudo bash setup. Okay, during the setup, let's write a simple C code to test. Okay, int main int x equals to non-determined int, and while, okay, it's while loop, x exploder x equals to x plus 1. Okay, while.c. Okay, the setup is completed, so we can run the translator using Python 3, SSA wrapper main, and the while.c. After the verification, the result is saved in a result folder. In the result folder, there's two folders, where the SSA code is saved in the ESBMC folder, and the C code is saved in the ESBMC.c folder. Let's check out the SSA code first. The SSA code is a little bit long, where the code is a bunch of assignments, and you can see that each assignment is getting longer and longer. Let's check out our C code. Our C code looks much better. However, as you can see, the condition is getting longer and longer. It is easy to see that in each condition, it's actually repeating the same thing. We can make a logical optimization to reduce redundant condition. So we run SSA manually with optimization level 1 to remove the redundant condition in the if statement. And the result shows that it looks much better. Also, there is another problem. Let's change the original file to add another variable, int y equals to non-determined int, and add another statement to the while loop, y equals to y plus 1. And run the ESBMC to verify the code. And translate with optimization level 1. The result shows that each if statement only contains one statement in the block. We can merge the if statement with the optimization level 2. As you can see that two statements are merged into one block. And the final optimization we can make is merge all the if statements into a for loop with optimization level 3. As you can see that the final result is merged into a for loop, which is really similar to its original code. And that's all the optimization we've done to the translator. Thank you for watching this video.